137 of Neetcode 150, reorder linked list. So in this problem, we are given an array or a linked list of integer, and we basically have to return something that it is a mixed up of the initial values and the end values. So just let me show you an example here. So for example, if we have this linked list that goes from 1 to 7, we want to render 1, then we want to render the last value, so 7. Then you want to render 2. Then, hopefully you guessed it, we want to return 6. Then we want to return 3. Then we want to return 5. And finally, we want to return 4. So I hope that this explanation, or more than 1,000 words, because this is really how to visualize it. This is the problem, and this is what we are supposed to produce. In the problem, we don't have to actually return something. We just have to modify the linked list. So how can we actually do this? So let me show you a wise trick here. For example, let's say that we have let's say we try to cut this linked list in two. So we have 1, we have 2, 3, and 4. And our second linked list will be basically 5, 6. Oh. Excuse me for this. All right, I guess I will have to try again. So anyway, let's say that we have two linked lists. First one is 1, then 2, then 3, then 4, and the second one is composed of 5, 6, and 7. All right. What if at this exact point, okay, we actually reverse the bottom one? So we are gonna have 7, 6, and 5. All right. Well, after this, it makes the problem way easier to conceptualize, because what we are going to have to render is basically the first element here. So we are just going to have to return 1, and then the first element here, 7, and then we just move on. We use the 2, right? And then we take the 6, and then the 3 here. So we just have to make sure that we keep, or we take the next values of each linked list, and we add this, or we actually position the next value to, let's say here, it will be positioned to 5, and here it will be positioned to 4. All right, so this is exactly what we are going to try to do, and let's start coding this. So well, first of all, we have to figure out a way to actually get our two sub linked list. To do so, we can use a fast and a slow pointer. So let's say that we start, or I'm just going to clean this up a little bit. All right, so let's say we start, or our slow pointer here, and our fast pointer is here. Okay, and a fast pointer is going to move by 2 every time. All right, so our fast pointer is going to be at 4, while our slow pointer is at 2. And once again, our slow pointer is going to be at 3, while our fast pointer is going to be at 6. And after this, we are going to have a fast pointer that will be basically equal to null here after the 7. And our slow pointer is going to be equal to the 4, or it's going to be at the 4. So by doing so, we actually have a pretty great way to start virtually dividing our linked list, because we are not actually going to cut it, right? We want to keep the space complexity of big of 1. But basically from this S, we can just take S.next, and you see that we can access to this, what you will call the second linked list. All right, so we are going to go ahead and basically say slow fast, where the slow is basically the first element, and then the fast is going to be head.next. All right, and now basically we want a while loop until fast is at null, or we might actually gonna get a case where fast.next is null. So we are gonna say while fast or fast.next. All right, this is gonna make the job. Well, we are gonna be willing to move our slow pointer by 1, and our fast pointer by 2. All right, that's it. Now we have access to basically the starting index of the second linked list. And after this, if you remember in the initial example that I gave, we actually want to reverse the second linked list. So all right, so let's basically say that the second linked list. So let's say second L. Let's call it second L. Okay, so this is going to be equal to the next element of slow. Right, so this is at this point, second L is going to be equal to the next element of slow, so it's going to be equal to our 5 here. Okay. And after this, we are going to be willing to also set, we are going to be able to reverse the linked list if we have a previous point here, and the previous gotta be equal to null at first, right? But there's one thing also that we have to take into account, is that once we sort of split these two linked lists, the value of slow.next, right? So once we have our once we have 1, 2, 3, and 4, basically at the end of the linked list, the last element is pointing to null. Whoa. All right. So we have to set basically the previous to null, and also the slow.next to null. All right. And not null for none, but none. And then we can while until there is a second, because by taking the next element, well, by saying that our second linked list starts at the element next to the slow, we know that the second list is gonna be smaller, so we can actually while loop until the second list is not empty. And what we want to do, it's basically that we want to hold temporarily the second value of or the next value of second L. This is actually at this point one of the previous problem that we did about reversing a linked list. It is exactly the same problem contained inside this one. Okay, so we are gonna keep. I'm not gonna go in depth on how to reverse a linked list, because this is something that you should already know if you did the reverse linked list problem. So when we are reversing a linked list, we want to basically set the next value to the previous one, so that the current one is pointing to basically the value to its left. So this is how you reverse the pointing order of a linked list. So, but by doing so, we are also destroying the link between the initial current and its next value. So this is why we have to keep track of it. So this is why we have our old value here, which is second L dot next. All right, and this is when we say second L dot next is going to be equal to pref. So at this point, the current value is gonna, or like the second L is gonna be pointing to the what used to be the previous, and then the previous is gonna be equal to the current value, so second L, and basically second L is gonna be equal to that value to the right, which is now hold, as second L that next no longer exists as it used to be. Okay, so now we have reversed our list, and I'm just gonna create some space here because I feel a bit short in the space I'm provided. All right, and after this, we have to create our logic for the first and also the second linked list. All right, so I will create first, well, if first a linked list, and also we have our second linked list. Okay, and the first linked list is basically going to be equal to the first element of the head we're given, and second linked list will be equal to pref, right? Because basically in the previous loop, we are going to break when second L is equal to none, meaning that the first element is going to be pref. All right, so we're also going to loop while there's a second list or linked list. All right, and basically this is where we want to keep the first element of first, but we want to set first dot next to the first element of second, right? Because this is where. So now we are at the point where we have our two linked lists, and the second one is actually reversed. So now we are at there 1, 2, 3, 4. So this is your first L. So this is that variable, and it starts here. And basically, second L in our code is actually this. So 7, 6, and 5. And now we want to keep first L. Basically, you want to say that this is equal to 1, but first L dot next has to be equal to this value here, right? So its next value has to actually point here. So second dot next has to be equal to this value here, 2, so that we actually get 1, and then 7, and then 2. All right, but when we point basically our value 1 to 7, we actually, by doing so, we break the link between the 1 and the 2. So we have to keep track of this value too. And same thing, right? When we actually we point 7 to the 2, well, we are breaking this link. So we have to create basically something that holds this for a while and something that holds this for a while, so that we can keep track of our value. So let's call it hold. Let's say we want to hold or keep, how can we call this, 1, and hold 2. Okay, so hold 1 basically, um, hold 1 is basically going to be 2, so it's going to be first L dot next, and same, right? Hold 2 is going to be equal to second L dot next. All right, so hold 1 is going to be uh, first L dot next, and hold 2 is going to be equal to second L dot next. All right, then once this is done, we can actually set first L dot next equal to second, which will give basically our 7. All right, and what do we want to do after this? We want to set second dot next equal to the second value of the first, which is now contained entirely in old 1. All right, and after this, the last step is basically to set up our first L and our second L to hold 1 and hold 2, so that we can go again in the loop, and after this we are going to take the next value again and again and again. So actually that's the solution, right? So I made a mistake here. Initially we have to make sure that fast and its next value are defined, so it is not a or, it is a and. So excuse me for this, and then wrong answer. So name second is not defined. Did you mean yes? All right, so there we go. So I hope you learned from this video. This was problem 37 of Neetcode 150, reorder linked list, and I really hope to see you in the next one.